Hello, fam. This is Zazu from Entertainment, reminding you that enthusiasm implies excellence. We are still continuing with our number pattern for grade 12, but now we'll be doing our quadratic sequence. As you normally know that every time when you start a concept, you start by defining it. So what is a quadratic sequence? A quadratic sequence is a sequence of numbers in which the second difference between each consecutive terms differs by the same amount, called a common second difference. So here we have a common second difference. It's a common second difference. If you can recall, on our first section where we were dealing with arithmetic sequence, we were having a common difference, but now a common is not the first difference that we get, but we get the second difference as the one that is common. Okay. One thing that we have to know is that our quadratic sequence has its general term, which is denoted by Tn is equal to an squared plus bn plus c. Okay. So a general term is an equation that we can use to find any terms that lie within that given sequence, if it lies within quadratic sequence. Okay, let me find first four terms of the sequence. Term number 1 is equal to, whenever I see n, I will replace n with 1. So it will be a times 1 squared plus b times 1 plus c, of which is equal to a plus b plus c. Our term number 2 is equal to a, whenever I see n, I'll replace it with 2 squared plus b 2 plus c, of which is equal to 4a plus 2b plus c. Moving to term number 3. Term number 3 is a, when I see n, I'll replace it with 3 squared plus b 3 plus c, which is equal to 9a. Let me write it in such a way that you will see that this one is a and this one is 9. Okay, 9a is plus 3b plus c. And my term number 4 is equal to a, where I see my n, I'll replace it with 4 squared plus b 4 plus c. This one is equal to 16a plus 4b plus c. So I said I'll be working with 4 terms. Okay. So here is my quadratic sequence. My quadratic sequence has term number 1, term number 2, term number 3, term number 4. My term number 1 is a plus b plus c. My term number 2 is 4a plus 2b plus c. My term number 3 is 9a plus 3b or plus c. And my term number 4 is 16a plus 4b plus c. Okay. Let me start performing my working. I want to find the difference between these terms because my intention is to know the sequence, in fact. So this is how I perform my working. So here, my term number 4 minus term number my term number 4 minus term number 3, I'll start by 16a minus 9a. That one will give me 7a. And then say 4b minus 3b, that will give me b. C minus c, that one will give me 0. Moving to term number 3 minus term number 2. 9a minus 4a, it will give me 5a. 3b minus 2b, it will give me b. And c minus c, it gives me 0. 4a minus 8 gives me 3a. 2b minus b, it gives me exactly b. And c minus c, that one gives me 0. So here you see that my first difference, there's nothing common in my first difference, meaning I have to continue with my working. I just got another sequence that requires me to work on also in order for me to find something that might be common. So I have to say my T3 minus T2, T2 minus T1. Okay. So here, T3 minus T2, 7a minus 5a, I'll get 2a. And b minus b, I get 0. 5a minus 3a, I also get 2a. And b minus b, I get 0. Now I do have a common difference, but it is a second common difference. And one more thing to pay attention on is that a quadratic, let me write here on the side. This one is a quadratic sequence, gives us an arithmetic sequence, in fact, and that arithmetic sequence is the one that gives us the common difference. So we call a QS a parent, and this is a child, and this is a grandchild. So I call this one a parent, calling this one a child, and I can call this one a grandchild for QS. So this is the way you can use to relate the three, in fact, to relate the three. But whenever you're required to solve a general, so if you want to find a general solution or a general term, a general term. If you are required to find a general term, we start from the child, and the child will direct us to, we start from the grandchild, in fact, and grandchild will direct us to its parent, and that parent will direct us to grandparent, of which is a grandchild, child, and parent. A real parent is a quadratic sequence. Okay. Let me now apply this thing in calculations. Okay. Here in my example, I am given the sequence of a 1, 4, 9, 16, 25, into infinite, because there is this 3 dotted that indicate that my numbers keep on growing. I don't know my last term. I only know these 1, 2, 3, 4 first 5 terms of the sequence. I am required to determine the general term of the sequence. Like I said, when we are required to determine a general term of the sequence, the first thing that we have to start by doing is to find differences. You have 1, 4, 9, 16, and 25. Okay. Now searching for your difference. Okay. 25 minus 16, that one will give you 9. 16 minus 9, 9, that one will give you 7. 9 minus 4, that one will give you 5. 4 minus 1, that one will give you 3. You see, you have a sequence. This is not a common difference, but it is a sequence. So meaning you have to continue with the working. Okay. Now you want to find T4 minus T3, T3 minus T2, T2 minus T1. So your solution here will be 9 minus 7, you get 2. 7 minus 5, you get 2. 5 minus 3, you get 2. Okay, now you do have your second common difference. Yours to do is to find the general term. You know that your second common difference is 2a. So your 2a is equal to 2. That means you have to divide by 2. We have to divide by 2. Your a now becomes 1. Okay. And then you move to this. You are done with this. You are done with the child. So the child is now directing you to its parents. Its parents is your arithmetic sequence. Okay. Our arithmetic sequence, we are going to deal with the first term. Our first term is we know that 3a plus b is equal to our first term of an arithmetic sequence, of which is this one. This is our first term for an arithmetic sequence, is 3. Therefore, here our 3a plus b is equal to 3. Now we know our a is equal to 1. So we'll be having 3 times 1 plus b is equal to 3. 3 times 1 is 3 plus b is equal to 3. That makes b be equal to 3 minus 3. Our b is equal to 0. Moving to our next step. We also know that our T1 or our first term for a quadratic sequence is written as a plus b plus c is equal to 1, of which is first term of the quadratic sequence. So you know your value of a is 1, you know your value of b is 0, you don't know the value of c is equal to 1. That makes c equal to 1 minus 1. Your c becomes 0. So going back to your general term says that your Tn is equal to an squared plus bn plus c. So you know your a is 1, you know your b is 0, you know your c is 0. Therefore, your Tn is equal to 1 times n is equal to n squared plus 0n plus 0n. That one is equal to 0. So this is your general term of this sequence. Moving to our next question. They say, which term in the sequence is 81? If they say which term in the sequence is 81, they are looking for the value of n, meaning you are going to use the above information, the general term that you got during your calculations, of which is Tn is equal to n squared. That makes your Tn to be 81 is equal to n squared. Okay, so you square both sides. So your n is equal to plus or minus 9, because you know that before your square root you have plus or minus 9. And you have to restrict that your n is equal to 9, comma, your n will never be equal to negative 9. Why? Because your n acts as the position. You will never have a negative position. You will never have a fraction position. A position will always be expressed in terms of natural numbers, yes, starting from 1 up to infinity. So this is all for today, but I don't want you. I don't want to leave you alone. I don't want to leave you alone, guys. I've decided to leave with you with yours to try. Given the quadratic sequence 2, 8, 18, 32, and 50, you are required to determine the general solution, or the general term, in fact, sorry, the general term of the sequence, and determine the sequence that is 133. I think this question is highly related to what I've just stated from my previous slides. Thank you, guys. I'm looking forward to meet you in my second lesson.